In this video, we are going to demonstrate how to take an image generated via the Xray tool in n4ce, clean out the noise, then trace over it to draw a 2D floor plan. Before we generate the Xray image, some things to note in this frame are the pixel size, which has been increased so the generated image will appear more solid. The resolution, which is set to 20,000 pixels, so the resulting pixel resolution for the size of this floor plan will be about 1 mm per pixel. And the section interval, which is set to 0.1 meters. Because the section is 1.8 meters deep, we will get 18 slices to build up the Xray. Assuming the image has been created, we will now load it into GIMP and use some clever filters that will remove the detail we do not want to keep. First, we use the Levels command to select the red channel and remove it entirely from the image. Then we repeat that step for the green channel as well. Because the data in the Xray image goes from red to green to blue, the more detail occurs in the image for each slice, the walls and doors will remain. Depending on if you prefer a white background, you can use the value invert option to do just that. Now, the file just has to be saved, and we can continue to draw up the floor plan in n4ce. We will start from a clean n4ce project where the image has already been dragged and dropped into the Images folder. If you are using the same project that generated the image, then you will need to right-click it and choose Reload in the Project Manager, as n4ce will not know the file has changed. To start with, create a new Cadd model to contain our floor plan. Then, double-click on the pencil icon to view it, and maximize the screen. Now click on the Backcloths button, or press Alt+B to show the Backcloth box. Click the Images tab, and then move the image over from the left to the right side, and press OK. Zoom to extents, and the image should appear. Before we begin detailing the floor plan, we will enable the rounding filter. This allows some tools to generate detail that is automatically rounded to a given precision. This ensures detail is consistent and not 1 or 2 millimeters either way of their realistic value due to slight registration or noise issues. In this example, we will round detail to the nearest 5 millimeters. We will now create a new layer to hold the floor plan. This automatically becomes the current layer. To begin with, we will draw a 3-point rectangle to best fit the exterior wall as accurately as we can. The building is not perhaps exactly square, but for the purposes of this demonstration, we will assume it generally is. We will now use the concentric rectangle tool to sketch in the internal wall. Click on the outer rectangle, and then nominate where the inner wall should be drawn. The offset box appears automatically, rounded to the nearest 5 millimeters based on where we clicked. Now we will make use of the Gap Extrude tool. This works by first selecting the segment to insert the extruded gap into, then where to start and end the extrusion. Note, lock modes are honored during this process. This is very important as it makes the tool both very powerful, but at the same time, easy to make mistakes. Select the Gap Extrude tool from the Lines Modify tab. We will start in the free lock mode and select the wall. Now zoom in and pick anywhere on the perpendicular wall to start the extrusion. Then, anywhere on the back of the same wall to define its width. Finally indicate the length of the extrusion. Note the dimensions box allows us to override the selected values. The first distance is the distance from the start of the segment to the start of the gap. The gap is the thickness of the extrusion, and the extrusion value is how far the extruded gap extends out perpendicular from the selected segment. Let's assume the walls are actually all 125 millimeters wide. If we untick visible, then the back-clothed image will be turned off. Now we will start a new extrusion from the very end of the extruded wall. The extrusion command is still active because we have not cancelled it, so select the segment to extrude, then in end lock mode, click near the end of the segment to start the extrusion from. Now indicate the thickness of the extrusion, followed by its length. Note the start distance is 0. Set the width to exactly 125 millimeters and press OK. Now, to do the opposite extrusion, we are still in the end lock mode. This time, we can use the end lock mode to not only indicate the start of the gap, but also the width of the gap, because all we have to do is click anywhere on the other side of the extrusion. The end lock mode will do the rest. Turning the image off to do a quick check shows the extruded walls look exactly as we would expect. Using what we have just seen, we can quickly extrude any wall. Just make sure the correct lock mode is set to begin with. Note, you can also use the keyboard shortcuts E for end and F for free. Extruding this gap, we will use the end lock mode to make it exactly the same length as the one next to it. But it's actually longer, so we will need to do this extrusion again. Ctrl+Z undoes the extrusion. Setting the lock mode back to free, we will repeat that extrusion, but this time to the correct length. At the beginning of this video, we stated the assumption that the building was square. Obviously, this is not always the case. We can accommodate this, if necessary, by using the stretch function to move the nodes at the end of this wall into the position indicated by the image data. In end lock mode, we can be sure to drop the wall just where we need it to go. As before using the free lock mode, we can extrude the wall to the right. For the other side, we have to be careful as the wall is not perfectly perpendicular to the opposite wall to the left. Therefore, we can't just extrude the wall out as before, or the door opening will not align correctly with the other side. Instead, we will parallel the wall thickness over to the opposite side of the door, then project that segment into the wall it comes from. Note the distance. The segment is being offset is also being rounded to the nearest 5 millimeters. Now, via the segment project option, we can indicate the segment and then the segment it needs to project out of. This box out can easily be drawn in via the segment pool option. Again, the dimensions of the box out can be overridden and are initially rounded to the nearest 5 millimeters. What to do, though, if the walls are not perpendicular? The wall the opposite side of this door is at an obvious angle. So the first thing to do is use the parallel option, again to offset the door opening to get the other side. Alt+M can be used to bring up the recent command list so that we don't have to go up to any menu or tab. The other wall will be started as any normal extrusion, but we will deliberately make it slightly short. We will draw in a partial line segment for the wall that's at an angle and then parallel over to get the back of the wall. Now we can use standard extend and merge functions to complete the join of the wall segments. First, though, we need to break the end segment out of the extruded wall. Now the standard merge tool can be used to extend these segments until they meet. The extend perpendicular to reference works for the first line, because it's just long enough to intersect. The second one is not though, so first we need to extend it enough so it will intersect. Using the normal merge tool, we can complete the joins, being very careful to indicate in the correct places, or we will not get the merge we intended. Later on, we will hatch the walls, but to ensure a clean result, we need to be sure our boundary is clean and continuous. One way to do this is to use the trace tool to weld all the line work together and make one complete polyline wherever nodes of separate line segments overlap. By right-clicking all the way back through the command history, the cursor returns to an arrow. Clicking on a Cadd element highlights it so we can see its nodes. Clearly, we have some separate elements that could be welded together with the trace tool. To do this, we must use the list command to select the lines we want to try and weld. We may as well select everything by using the invert option. Any element in the list will then appear dashed. Now, with all line elements in the list, we can click Trace. Note those elements not welded stay in the list and don't revert back to their original line style. Clicking on the wall shows it's all one polyline now. We will now jump to a different section of the floor plan. This section has a small closet that means we need to join two extrusions in order to form the closed area. Initially, we will use the extrude command to go around its outside, making use of the appropriate lock modes where necessary. Then parallel the door opening as before and project it into the necessary wall segment. Now we can start the extrusion to form the closing wall of the closet. Then, using the end lock mode, when specifying the start and end of the second gap, we can ensure it's drawn out perfectly perpendicular from the opposite wall. Making sure it is drawn short, the two end segments can then be broken out and the two lines closed to maintain the integrity of a complete polyline. Moving away from inserting walls for now, we also need to punch holes in them where there are door and window openings. To do this, we use the Gap Project tool. This allows us to make a hole in both sides of the wall and join them to form an opening. It works in a similar way to the Gap Extrude tool. Making sure the correct lock mode is selected, indicate the segment, followed by the start and end of the hole, and then the opposite wall that needs to be opened as well. This provides a very quick and clean method to make openings for doors and windows, especially if they must be to industry standard sizes. Fast forwarding a bit, we will now look at how we can insert windows and doors into their respective openings. For the windows and doors, we will use pre-existing symbols in the symbol library. If you do not have them, you can import them from existing floor plan drawings as blocks, or just draw your own. For this floor plan, we will load in doors opening in and out, plus a double window to start. Note, these are 2-point symbols. They have an origin and handle. This is not something AutoCAD supports, so you may need to explode existing symbols and then redefine them to have 1 or 2 handles in n4ce. An example of how to do this will be demonstrated shortly. Now we can use the 2-point scaled function to insert the correct door into the appropriate openings, using the lock mode end to make sure the door is correctly located. A double window is actually the incorrect symbol for this opening, but it will still work for our demonstration purposes. Not only is the symbol the wrong one, but it's too thin. The scaling is applied proportionally in the axis of the symbol, but in this situation, that is not enough. It would be better if we could use a third point to specify the thickness of the window. To do this, we need to duplicate the symbol, but set it up to use an origin and 2 handles. So we will undo it, then go about setting up a new window symbol to use 3 points. Using the 1-point place tool, we place a copy of the double window. Then explode it. That converts it back into basic Cadd elements. From the Symbols tab or menu, select the Create by Rectangle tool. Having selected the elements that make up the window, n4ce prompts us to indicate the origin of the new symbol in the bottom left of the screen. Using the end lock modes, we then click on the bottom left for the origin, then bottom right and top left corners of the window for the handles. Right-clicking brings up the symbol Create box. Give the new symbol a suitable name, and make sure the options are set as they are here. Setting elements to by block ensures we can change the color of the symbol later if we need to. Otherwise, its color will be fixed as it is now. Now we can delete the symbol and try to reinsert it using the 3-point option to test it. That seems to work fine, so we can fit it into an appropriate opening. Note, the end lock mode has no effect if there is nothing suitable to lock to. Using nothing but the tools we have just been exploring, the rest of the walls can be completed with ease. Before going on to insert the relevant windows and door symbols, we will hatch the walls to make them clear. Hatches work best with clean, continuous polylines. So, as before, we will use the trace tool to tidy up any loose line work and weld it all together as much as possible. As we have no other line work in the view, we can simply invert the list to select everything, then click Lines Trace to tidy the line work up. Finally, we will clear the list so we don't accidentally operate on the listed elements if the pick mode was also set to list. Normally, it's sensible to hatch a small part of the plan first just to test the settings, so we will do just that. From the Hatches tab, we will use the crosshatch indicate command to hatch one of our wall elements. First, we click an element, and then right-click as for now, we only want to hatch one wall as a test. The Hatch Properties box will appear. Select an appropriate pattern and check the scale. This is usually what needs altering. Otherwise, the hatch can be too dense, or go the other way and be too sparse. For our first test, we will try a factor of 0.2. Using an appropriate lock mode, click the origin for the hatch, and then a second point to control its orientation. That hatch actually looks okay, so we will press Ctrl+Z to undo it, and then using the hatch by all elements inside a rectangle, hatch all the walls in one operation. Just as before, we specify the hatch pattern to use and the scale. Then indicate an origin and orientation point. With the walls complete, we will quickly skip over the process of inserting all the other windows and doors. Finally, with that done, we can start to place some dimensions down as well, should they be required. As version 4.40D also allows Cadd to be shown in the 3D view, we will set the height of all the elements to the correct ground level, and then backcloth the Cadd model into the model we used to open the point cloud. Then we can see the Cadd drawing and the point cloud at the same time, in the same view. To do this, we will enter the desired level in the height field, then use Attributes Height Set in Rectangle Pick mode to set all the elements on screen to that level. Now, if we switch to the 3D view that has the point cloud loaded and we backcloth the plan into it, we can check for any mistakes. The point cloud can obviously be turned on and off, as well as altering its opacity to help visualize both the scan and the plan together. That completes this tutorial.